Hello everybody and welcome back to another brainstorm. Today we're going to be talking about recurring decimals. I'm going to split this video up into two main parts. First of all, we're going to discuss what exactly is a recurring decimal, and then we're going to talk about how we convert them into fractions and do some practice questions together. So let's get into it. Alright, so before we discuss anything else, we need to talk about what is a recurring decimal. So a recurring decimal is one which goes on indefinitely. So we've got an example of one here, 5.66666, but the main point and what indefinitely means is that these sixes go on forever and ever without an end. And this is shown with a little dot above the repeated numbers. So if we take this one for example, we see that the number repeated here is the 6, so instead of writing out all of these sixes, we put 5.6 and we put a little dot above the 6 to show that it's repeated on and on and on. Alright, so here we've got three examples of recurring decimals, and each one of them you can see the little dot to show us which number is going to be repeated. So the first one is 3.3 recurring, and the dot is above the 3, which tells us that the 3 is going to go on and on and on, so it's 3.3, 3, 3, 3, and those 3's will go on forever. Then the next one, we've got two numbers with a decimal point on. Now this can be a bit confusing, but all it means is that both the 1 and the 5 will be repeated, so it will be 2.151515, and that'll go on forever. It's important to keep the 1 and the 5 in the order that they appear. Then here we've got three numbers. Now although the 2 doesn't have a dot on it, because it's sandwiched between a 1 and a 3, these three numbers are all repeated. So this will be 0.123, 123, 123, and that pattern of 1, 2, 3 will go on forever. Okay, so now we're going to talk about how do we convert these guys into fractions. So in maths we often convert our decimals into fractions simply because it's a lot more accurate. So here is a typical exam question that might come up for recurring decimals, and it's simply write 0.3 recurring as a fraction. So the first thing that we say is, we're using a bit of algebra here actually, let x be equal to whatever recurring decimal we're given, so in this case it's 0.3 recurring. So what we mean by that is we're saying that x is equal to 0.33333 ... goes on forever. So now the key here is we need to find another form of x that has the same numbers in the same order after the decimal point. So the obvious one here is 10x, because if we times this up by 10, decimal place shifts forward, and now we have 3.3333 ... goes on forever. So now our main goal is to get rid of all of these 3's after the decimal point. Simple way to do that is we just minus x from 10x. So 10x take away x is 9x, and 3.333 minus 0.333 is we're just getting rid of all of those numbers, so we have 3 left over. So now we've got simpler numbers to work with. We divide both sides by 9 as always, so x is 3 over 9. And now we have got a fraction, but it always has to be in the simplest form. So 3 over 9 is 1/3, and that's our answer. It tells us that 0.3 recurring is the same as 1/3. Okay, so we're going to do another example question, which is a little bit trickier than the other. This time it is write 0.81 recurring as a fraction. So once again, we're going to say let x be equal to 0.81. But you see, because we've got the recurring dots above both the 8 and the 1, we're saying this time that x is equal to 0.818181. Okay? So remember, it's important to keep these 8 and the 1 in the right order. This time, if we scale up to 10x, we face a bit of a problem, because you see, if we move that decimal point 1, we've got 8.181818. These 8's and 1's are in the wrong order. So we have to scale up again. So now it's 100x. We shift it forward. So we can see that that is equal to 81.818181, and we're back to that 8-1 pattern just as before. So remember, we've got to get rid of all of these numbers after the decimal point, so we're going to minus here. So 100x take away x, 99x, is equal to 81.818181 minus 818181. So we're going to get rid of those, left with the 81, so 99x is equal to 81. X is equal to 81 over 99. We've got to simplify that down, divide the top and bottom by 9, so it's going to be 9 over 11. So we can see that 0.81 recurring is equal to 9/11. Okay, so now let's look at one final exam question just to wrap things up. So it says write the numbers below in order starting with the smallest. So as always, the key to any ordering question is to get all of these numbers into the same form. So for the sake of this example, we're going to put them all into a recurring decimal. This one's already in a recurring decimal, so we don't need to worry about that. But it's just so we don't have to fiddle around with the denominators. So we can do these with a calculator. That's how I'm going to be doing them, just for the sake of time. Or if you don't have a calculator, you can do these using short division. It's up to you, really. So 5 over 11, that gives us the recurring decimal 0.45. Both the 4 and the 5 are recurring. And 11 over 23 gives us 0.478. And there's loads of numbers after that which are recurring, all of them. So here we've been given 3 numbers to work off. So let's put all of these to 3 numbers. So 0.478, 0.472, 0.454. You can imagine that 4, 5, 4, 5 there. So now we've got to put them in order, starting with the smallest. We can see that the smallest is this one here. Second biggest is this one here. And the biggest one is here. So whenever giving our answer for an ordering number, we have to give it in the way that it's stated here. Okay, so the smallest one is going to be 5 over 11. Second largest is 0.472, ... And the largest one is 11 over 23. And with that, I'd just like to say thank you guys all for watching. Please make sure you hit like and subscribe if you want to see more videos like this, and I'll see you guys soon.